are going to discuss. Please use a different colored pen because like yesterday, I see some of you macam, because your friend's answer is in pencil, and then you were also marking in pencil, so I don't know which one is your friend's answer or which one is the correction. If you don't have a different colored pen, maybe you can borrow from your friend or the person whose paper you are marking, okay? Right, are you ready to go through the questions? So for this question one, they give you a series of reactions to transform carbon to molecule compound X. So this is an example of an organic synthesis again. Okay, so before I give you the answers, I'll just go through quickly what happens in this multi-step production. Okay, so the first step, we are adding the alkyl group. So that's an alkylation, but the mechanism is, or when they ask you the type of reaction, don't answer alkylation or Friedel-Crafts alkylation. Please write down the mechanism, okay? So Friedel-Crafts is an electrophilic substitution. So I'll just add in alkylation. Okay, the next step, step 2, you are adding nitro group, NO2. So that's a nitration. Step 3, you are turning NO2 to an NH2. That is called a reduction. So that should already answer your question, step 1 and step 3. Yeah. Step 4, there isn't a name for this, but it's the production of diazonium ion. So that N2 plus, N triple bond N plus is the production of diazonium ion, and then for step 5, from the diazonium ion to phenol, this is called a substitution reaction, or they also accept hydrolysis because you need water to break that carbon-nitrogen bond, to break this bond. It's called hydrolysis. Step 6, if you notice, what's changed is the delocalized system is gone or broken, so that is reduction or hydrogenation. Or reduction. Why is it called reduction? Because you gain hydrogen. Okay. Right. So to answer the questions on the next page, the mechanism is called electrophilic substitution, which is the Friedel-Crafts acylation. The type of reaction in step 3 is reduction. The type of reaction in step 5, as I said just now, is substitution. They also accept hydrolysis. The reagents and conditions for each of the following steps. Step 1, we are adding that molecule, okay, with a CH3, CH2, and a CH3. So you have to attach that to a halogen, either chlorine or bromine, okay? Chloroalkane is not enough. I know that's what it's written in your notes, but you need to give a specific reagent, okay? So the easiest one for this is to write down the structural formula, CH3, CH2Cl, and a CH3, okay? Or you can also do CH3 to CH2Cl. If your friend wrote down Cl at the end, which appears like a primary halogenoalkane, it is wrong. This has to be a secondary halogenoalkane. Okay, so to answer that question, the reagent is CH3 to CHCl. You need a catalyst, AlCl3 or FeCl3, and heat. I forgot to emphasize this in your notes, but heat is required for the Friedel-Crafts alkylation or acylation. Okay, it's mentioned in your learning objectives, but not so much emphasized in your notes. Step 2 is a nitration process. That one, nitric acid, concentrated sulfuric acid, and if you have these two, you get 1 mark. Temperature 55 degrees Celsius or above. Okay. Step 3 is the reduction process. You need tin and hydrochloric acid for 1 mark. You must have both the reagents in order to get 1 mark. Okay. Step 4 is the production of the diazonium ion. You need nitric acid, or you can write down NaNO2 plus HCl, because you need the sodium nitrite and the hydrochloric acid to form the nitrous acid. Sorry, it's not nitric acid, it's nitrous acid. And the temperature below 10 degrees Celsius. Okay, so these two temperature must be mentioned in order to get 1 mark. If one of the temperature is missing, then your friend should get 0 mark. Okay, and this is 1 mark. That's how you get 6 marks. 1 mark for writing down the correct chloroalkane and the catalyst plus heat. 1 mark for writing down nitric acid with concentrated sulfuric acid. Nitric acid is the reagent. Concentrated sulfuric acid is the catalyst. 1 mark for writing down tin and HCl. 1 mark for writing down nitrous acid or sodium nitrite with HCl. And the last mark goes to writing down the temperature for both reaction. If one of them is missing, then that's a 0. Okay? So the good thing about learning to mark your friend's work is that you also know how to get the marks and how you can lose marks, essentially. Okay? So 6 marks, easy 6 marks, I feel. Sorry? 5. You're right. 1 more. Yes, sorry. This is 1 mark, and this is 1 mark. Okay? So the halogenoalkane is 1 mark, and the catalyst is a different mark. So if your friend got the the chloroalkane wrong, but there's the presence of a catalyst and heat is not mentioned. So as long as your friend mentions a catalyst, then you can get him or her 1 mark. Okay? So thank you. 6 marks in total. 1, 2, 3, 4, 5, 6. Okay. Any questions? Any other questions? All right. Moving on to question 2. When benzene reacts with SO3 benzene sulfonic acid, benzene sulfonic acid is, when benzene reacts with SO3 sulfur trioxide, benzene sulfonic acid is produced. The mechanism is similar to that nitration of benzene. Okay, so you've already did this yesterday, the mechanism. This time you have 3 marks. The first mark is for drawing an arrow from the benzene ring to the SO3H+. Second mark is for drawing the correct intermediate. Okay, make sure you check also the broken delocalized system. It should extend around 5 carbon atoms except the atom where you attach the SO3H group. Okay? And so that's 1 mark. The last mark is for breaking or drawing the arrow from carbon-hydrogen bond back to the broken delocalization. So that's 3 marks in total. Write an equation to show how the H2SO4 catalyst is reformed. So you want to reform H2SO4 using, so from this mechanism, you release H plus, okay? So you want to react H plus with HSO4 minus, okay? So HSO4 minus, if you look at that, plus and minus, it cancels out, and the hydrogen now becomes 2, H2SO4, and that is how you reform the catalyst sulfuric acid. Okay, where do I get this HSO4 minus from? Is from the production of the electrophile. Electrophile is being used, but this ion is just floating around in that reaction mixture. Okay, next one. Suggest the reagents and conditions and name the mechanism. So same thing, you attach C12H25. That looks like an alkyl group to me. It's an alkyl Friedel-Crafts alkylation. Reagents and conditions. You need, again, chlorine, C12H25. You can use bromine as long as the catalyst matches, okay? If you use chloroalkane, AlCl3 plus heat. If you use bromine, C12H25, then you would use AlBr3 plus heat, okay? And that is for 1 mark. Please mention your heat. If your friend wrote down C12H25Cl, that's also correct. Okay, whether the Cl comes at in front or at the back, that's correct. Mechanism is electrophilic substitution. Okay, any questions so far? Okay. Next, and the last question is to discuss the acidity of the given carboxylic acids. Okay, so you're given pKa. pKa is actually negative log of Ka. The way I see it, pKa is just like pH. The lower the pH is, the more acidic it is. Okay, so it looks like this is the most acidic, and aminoethanoic acid is the least acidic. Okay, lower pKa, more acidic. Okay, the question just wants you to give reasons for why the pKa value for chloroethanoic acid is smaller than that for ethanoic acid. So we want to talk about acidity, okay? Ethanoic acid looks like this with just CH3COOH. Chloroethanoic acid is when you have a chlorine, okay? This chlorine actually has an effect, right? What effect does chlorine have in terms of electron withdrawing or electron donating? Does it donate or withdraw electrons? Okay, it withdraws electrons. So I will draw the arrow going towards chlorine. Okay, so when we talk about acidity, so in fact this is more acidic than ethanoic acid. Okay, less acidic. Okay, now there are two factors to look at when we want to talk about acidity. What are the two factors? Two explanations when talking about acidity. Apa, what do you see on your friend's paper? What do they talk about? Sorry? Charge density, okay, yes. On the right track. Anything else? What's on your friend's paper? Stability, yes. Stability and charge density go hand in hand. Lagi, there's one more I'm looking for. One other reason. Electronegativity is talking about the electron withdrawing effect of chlorine, yes. The other explanation, do you see any your friend giving anything else other than what's been mentioned? I'm looking for one more. Did any of your friends talk about the strength of OH bond? Yes, ada. Okay. Right. So we want to explain why chloroethanoic acid is more acidic than ethanoic acid. First, we mentioned chlorine is electron withdrawing. And then just now someone mentioned electronegativity due to high electronegativity value, 2 marks. Okay? So what the chlorine does is that it stabilizes the COO minus ion by removing electron density. So someone mentioned that just now. Okay? Or, so first mark is for mentioning that chlorine has an electron withdrawing effect. The second mark is either you can talk about the stability of the COO minus ion, or it weakens OH bond, so more H plus is released. Okay, so for this question, you can choose either one, but if the marks, they give bigger marks, like 3 or 4 marks, you must mention about the stability of the anion as well as the strength of the OH bond. Okay, in this case, either one should give you the mark. Okay, but please also write down whichever is not on your friend's answer. You write down that's for them. And then once you're happy, you sign, you show your friends their mark, and then later on I will collect it. Okay, so your paper yesterday I've already written to you. There are some adjustments made, like your friend marked you correct, but actually you are not awarded that mark. There's also cases where I was lenient to give you mark that you shouldn't have gotten. So I still need to check the papers even though your friends have marked them. Okay, so please return to your friend. And then before you go, drop off the paper so I can have a look at them again, just to make sure that your marker is doing the correct marking. And don't forget, you have a paper 5 to do over the long weekend. Right. You done? You happy? Yeah. Okay. I'll have a look at them again and